When you picture the planet Saturn, you probably don't just imagine a giant ball of gas. You see the rings, wide, bright, perfectly circular, like someone carefully placed a cosmic vinyl record around the planet. It's so iconic that if Saturn didn't have rings, it almost wouldn't feel like Saturn at all. But here's the real question. Why is Saturn the only planet with rings, or is it? Today, we're diving into the science, the surprises, and the hidden truth behind planetary rings, right here on History of Simple Things. Let's clear up the biggest misconception immediately. Saturn is not the only planet with rings. All four gas giants in our solar system have ring systems: Jupiter, Saturn, Uranus, Neptune. The difference is visibility. Saturn's rings are enormous, bright, and highly reflective. The others have rings too, but they're faint, dark, and difficult to see without powerful telescopes. So the better question isn't why Saturn is the only planet with rings. It's why Saturn's rings are so spectacular compared to everyone else's. What are Saturn's rings made of? Saturn's rings are not solid disks. They're made of countless particles, mostly water ice, with some rock and dust mixed in. These pieces range in size from tiny grains to chunks as large as houses. Because they're made largely of ice, they reflect sunlight extremely well. That's one major reason they appear so bright and visible from Earth. The rings stretch about 280,000 kilometers across, but surprisingly, they're incredibly thin, often only about 10 meters thick in many areas. How did Saturn get its rings? Scientists believe Saturn's rings formed from material that never became a moon, or from a moon that was torn apart. This brings us to something called the Roche limit. The Roche limit is the distance at which a planet's gravity becomes so strong that it can rip apart a nearby object held together only by its own gravity. If a moon drifts too close, tidal forces stretch it, fracture it, and eventually shred it into debris. That debris then spreads out into orbit, forming rings. Some studies suggest Saturn's rings may be relatively young in cosmic terms, possibly only 100 to 400 million years old. That's surprisingly recent compared to the age of the solar system, which is about 4.5 billion years old. Why are Saturn's rings so much bigger? If Jupiter, Uranus, and Neptune also have rings, why don't theirs look like Saturn's? The main difference is composition and brightness. Jupiter's rings are made mostly of dust, probably debris knocked off its small inner moons by meteor impacts. Dust doesn't reflect much light, so the rings are faint. Uranus has narrow, dark rings made of rocky material that reflects very little sunlight. Neptune's rings are also thin and clumpy, with uneven arcs instead of wide, smooth bands. Saturn's rings, by contrast, are packed with water ice. Ice reflects sunlight extremely well, making the rings brilliant and easy to observe. Why don't Earth or Mars have rings? Rocky planets like Earth and Mars don't have rings, but they could. If a large asteroid broke apart within Earth's Roche limit, it could theoretically form a temporary ring. In fact, some scientists believe Mars may have had rings in the distant past, formed from a moon that broke apart. But smaller planets have weaker gravity. Over time, ring material either falls into the planet or clumps together to form new moons. Gas giants, with their enormous mass and strong gravitational fields, are much better at maintaining stable ring systems for long periods. Saturn's rings aren't just floating randomly. They're shaped and maintained by its many moons. Small shepherd moons orbit near the edges of ring gaps, using gravity to keep particles in line. These moons prevent the rings from spreading out too far or collapsing inward. For example, Saturn's moon Pan orbits inside the Encke gap, clearing a path through the rings. Without these moons, Saturn's rings would look very different. Will Saturn always have rings? Probably not. Saturn's rings are slowly changing. Tiny particles gradually spiral inward due to gravitational interactions and something called ring rain, where charged particles fall into the planet's atmosphere. Data from NASA's Cassini mission, which orbited Saturn from 2004 to 2017, showed that the rings are losing material over time. Estimates suggest Saturn's rings could disappear in about 100 million years. We happen to be living at a time when Saturn's rings are especially prominent. Here are a few surprising facts you might not know. First, if you could somehow scoop up all of Saturn's rings and compress them into a single object, scientists estimate the total mass would be only about the size of one medium-sized moon, possibly similar to Saturn's moon Mimas. Second, Saturn's rings actually have temperature differences. Even though they're far from the Sun, parts of the rings can reach around minus 180 degrees Celsius, depending on how much sunlight they receive. And finally, the rings aren't silent. Data collected by NASA's Cassini revealed radio emissions created by interactions between the rings and Saturn's magnetic field, meaning the ring system produces detectable sounds in space. Saturn isn't alone in having rings. It's just the showstopper. Its icy composition, strong gravity, complex moon system, and possible history of shattered moons all combine to create one of the most breathtaking sights in our solar system. The rings aren't permanent, they're not solid, they're not unique, but they are a reminder that even in the vastness of space, timing and physics can align to create something extraordinary, at least for a while. And that's the real story behind Saturn's famous rings. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.